Hey Mod, can you hear me now? Alright, hopefully by now we all realize that gradient, this word right here, that means slope. So if we want to find the slope between these 2 points here, we're going to use our gradient formula. This guy, y2 minus y1 over, x2, x1. Alright, and it really doesn't matter which one you pick. I'll pick this one first. So this will be my y2. So 9 minus my y1, 3 over 4 minus 2. That's going to give me 6 over 2, which means my slope is 3 here. Part P. Okay. Find the gradient of a line perpendicular. Perpendicular. That's opposite reciprocal. So that means for this part, I change this slope to negative 1 over 3. Boom. That's the answer. Part C. Got to change it to this form with an equation of the line. So I always start where they asked me to start. So it says, what is the value of B? So I got to figure out what this guy is right here. So put this in a form that you recognize. All right. So 2x plus by minus 12 equals 0. Let's change it to y equals mx plus b form. Okay. So I'll do minus 2x minus 2x. Get by minus 12 equals negative 2x. And then plus 12 plus 12. And I get by equals negative 2x plus 12. All right, so now I got to get this y by itself. So what happens? I divide everything by b. B. So this goes away. Go away. I don't like you anyways. All right, so now I'm left with this. This is what's important now. So remember, this is the equation of the perpendicular line. So I want to pay attention to the slope here. So this is negative 2 over bx. So then negative 2 over b is my slope. So if they tell me that my perpendicular slope is supposed to be negative 1 over 3, then I know negative 1 over 3 has to equal negative 2 over b, because it's my perpendicular slope. Well, what value of b will give me negative 1/3? Let me get a calculator. Oh, okay, it's 6. Yeah, b equals 6, because negative 2 over, is it 2 over 6 equals negative 1/3. There you go. Quick maths. All right, for those of you who are still confused, I'll do this again. 2x plus by minus 12 equals 0. This is what's given to us, okay? This is the equation of the perpendicular line. We know from part B that we figured out that the slope has to be negative 1/3, which means that the slope here has to be negative 1/3 too. So I just put it in a form that looks familiar. Slope intercept form. Slope intercept form. So 2x minus on both sides. Trying to get y by itself. by minus 12 equals negative 2x. Now, plus 12 plus 12. Now I have by equals negative 2x plus 12. All right, now last step, get y by itself. I'm dividing everything by b. So now look what we have here. Important, this is where we get our slope from. We already know that the slope is supposed to equal negative 1/3. So if we have negative 2 over b, here, this has to equal negative 1/3, what we got in part B. Up here, right here. So, if I have negative 2 over b here, negative 1/3 here, something that you should remember, I'm sure most of you do, is cross multiplying at the very least. Let's do that. So, like that, cross multiply, so that you'll get negative b equals negative 6, which means b equals 6. There you go. And yes, I'm using B because I'm colorblind. I'm sorry, and I'm using blue because I'm colorblind. Tamani, you can solve for any variable you want at any time. It just depends on what you're given. So we know that we're given that our slope for this line has to be negative 1/3. So if I get an equation that just says, here, let me try it. So negative 2 over b, that's my slope here. After I got y by itself, I get negative 2 over b. But I know it has to equal negative 1/3 because in the previous section, we got negative 1/3 for the perpendicular slope. So if I know, oh, to be perpendicular, I know this has to be negative 1/3. So there's only one value I can put here for b to make this whole thing negative 1/3. Here, I'm just going to go over this problem real quick. Well, not quick, just review it extensively because this is the meat of the test right here. You need to be able to do this. All right, I'll start this off. Okay, here's our equation. Point P is located on the curve where x equals 3. So there's some point on the curve where x is 3, but we don't know why. We just know there's a point on the curve, 3, comma something. So right here for part A, it says find f of 3. Well, for this, you're finding that y value. That's what that means. Remember f of x, that's the same thing as y. So it says find your y value when x equals 3. So if x equals 3, I put it into my equation because this is f of x up here. So I'll do this. I'll say, okay, f of 3 equals 3 to the 5th power plus 3. So then what would that be? Let me get my calculator because I'm really bad at math. Okay, 3 times 3 times 3 times 3 times 3. Oh, it's 243. Ooh, that's big. Okay. So 243 plus 3. We got my calculator again. See, clear that. 243 plus 3. Okay, that's 246. I knew that. So then when my x value is 3, my y value is 246. Don't forget that. F without the little symbol here means just find the y value here. Now part B. Notice a little symbol here. This means derivative. Find the derivative of this. So I use the power rule. So I'm going to do 5x4 and then plus. And then you see here, that's a 1. So I bring the 1 down in front. I just have that. So this is my derivative. If you missed that, I'll do that one more time. So look, over here. I'll do x to the 5th. Bring the 5 over here, plus x to the 1st, bring the 1 over here, which gives me 5x to the 5 minus 1, plus 1 times x to the 1 minus 1, which gives me 5x to the 4th, plus 1, almost messed it up, 1, and then x to the 0, but that gives me 1, so you can leave that out. So that's my derivative. Now here's the part y'all get confused about. Find the gradient of the tangent line. The gradient. This means derivative. This is the derivative. So when I'm looking for the gradient, we're always going back to derivative. If you see this word gradient, think derivative. So it says find the gradient of the tangent to the graph of f, because this is the derivative of f. That's what this means at point P. So at point P, we need our x value. That's what's going to give us the gradient. So here, I know, I'll do it here, part C. My derivative is x, or 5x to the 4th power plus 1. I know that point P has x equals 3. So I'll say, okay, I want my gradient, my slope, using this equation when x is 3. So I'll say my slope, this is what this means, when x is 3 equals 5, 3 to the 4th power plus 1. This is going to give me, okay, so this is one thing I see people mess up all the time. Just type this in the calculator just like that. A lot of people are putting this number to the 4th power. No, it's only this number to the 4th power. So this number to the 4th power would be 5 times 81 plus 1. Let me go get my calculator again because I'm bad at math. So 5 times A1 equals 405. I don't know how much that is. 405 plus 1. Get my calculator. Always gotta check my work. I wish some of you would do this too. So 405 plus 1. Oh, give me 406. Cool. So this is my slope. This is my m, okay? So I've got x, I've got m. What's wrong with my m here? I don't know what happened. And then I've got my y value here. So I'll write that here, y equals 246. Okay. Now I can start writing equations, okay? So part D, find the equation of the tangent line. That's all it's asking for. Use this. Don't make yourself more difficult than it already is, just as high school. So I just put in my point here, here, and then put in my slope. And that's the answer. So y minus y1, 246. Y minus y1, keep messing up. Y minus 246 equals, my slope is, 406. And then x minus my x value is 3. This is the answer. Okay? Don't make it life complicated. Now part E, write down the gradient of the line perpendicular to this line. So if this is my slope, I want a perpendicular slope. So it's just -1/406. Not that difficult. Okay, next, last part. If I can just make this thing. There we go. Part F. Find the equation of the normal line. So again, not hard. I'm using this again. This is in your formula booklet, just in case you didn't know. All right, so now my new slope is equal to -1/406. I'm just gonna replace this number with this number. So now I have y minus my y1 was 246 equals, now my new slope, 1/406, or -1/406, x minus 3. There you go. That's it. All right, so when talking about perpendicular slope or normal slope, let's say, draw a box here. Let's say I have a line, this is the equation, y minus 3 equals -1/4 x minus 5. And I say, oh, what's the normal line to this tangent line? Oh, perpendicular. So first thing I'm gonna do is change this. Flip it, change the sign. So I flip it, so now it's 4/1. Change the sign, it's positive now. So this is just 4. So the normal line would be this. 4x minus 5. All right, for those of you in IB applications, this is the definition of the derivative, this right here. Oop. Here we go. Definition of the derivative. All right, so here, this is actually easy because they set it up for you already. All you're doing is the algebra. Okay, so they're saying just expand the numerator. That means get rid of these parentheses here. So if I've got 2x plus h, and also applications, you have a question exactly like this on the test. I just changed the numbers, that's all. Squared minus 3x plus h minus 2x squared plus 3x. So they just want you to get rid of these parentheses here. So here, x plus h squared, that is going to be 2x squared plus, and then I'll do x times x is x squared, x times h is xh. So 2xh plus h squared, like that, minus 3x plus 3h minus 2x squared plus 3x. So then here we still have parentheses here, so distribute. So 2x squared plus 4xh plus h squared minus 3x. This would be an h here. Plus 3h minus 2x squared plus 3x. Yeah, that's supposed to be an h because I distributed this here and here, and then that should be negative and negative, sorry. All right, so now that's part one. Part two is to simplify this now. So I can cross out this because 2x squared minus 2x squared is 0. Then I have, oh look, negative 3x plus 3x cancels out. And on the numerator, all I'm left with is 4xh plus h squared minus 3h. And so now it's all over h. See? So now for part three is just simplify and evaluate. So cross that out, that one, and that one. So what am I left with? I'm left with 4x plus h minus 3. Now it says here h goes to 0, so I put in a 0 here for h. So 4x plus 0 minus 3. And so what am I left with? I'm left with 4x plus 3. That is your derivative. So this next one, everyone has something like this. All right. So here, all they're trying to get you to recognize is what's happening to your derivative on this graph. So this is not the derivative, this is the original function f of x. So we're saying, all right, based upon what we have here, can we say what happens to the derivative? That's this, the gradient of the curve, the derivative. So if you look here at point C, if I draw a line, which will be my gradient at this point C, that's just a straight line. So the gradient here is 0. So the gradient equals 0 because at your max and min, you will always have gradient equaling 0, always. Because look at here for A, that's a minimum. Gradient is 0, straight line, horizontal line. Now for part B, if I'm going from B here to C to D, they're asking what's happening to the derivative. That means derivative, what's happening to the gradient at those points. So here, if I go from B to C, I'm going up here like that. My gradient is positive, so positive gradient means I'm increasing. And then here, at C, we said, look, it's stagnant or stationary. So if it's stationary, it's neither increasing nor decreasing. So we say at C, it is stationary. And then if I'm going from C to D here, going down, which means my derivative is negative. So negative gradient. So it's decreasing. So from B to C, it's increasing. At C, it's stationary. And from C to D, it's decreasing. That's it. That's all you have to write for the answer. Next one here. So again, it says, for what values of x is the derivative, that's the little apostrophe f, derivative equal to 0? So again, when it's equal to 0, we're looking for maximums and minimums, or anywhere where the slope will equal 0. So look here, I can see one right here, boom. The slope right here, that's a stationary point, that equals 0. So what value of x is there? 3. So I've got x equals 3. Look here. Again, horizontal line, slope is 0 here. What's my x value? 5. And then this last one you can see here, this is called an inflection point. This is something we'll talk about more in HL, but really all we need to see is that, look, even if I draw a line here, it's still stationary right there. So boom, what value of x is that? Oh, 7. So all of these values here, the slope of the derivative equals 0. See, I even drew the lines. Now here, it says for what range of values of x. So for what values of x is my derivative, that little apostrophe, less than 0? When is it negative? I want negative gradient. So here, I need to know when my graph is doing this, decreasing. That's decreasing and decreasing my bank account. So, okay, look, I'm decreasing here. Do I see decreasing anywhere else? No, it's positive, increasing, positive, increasing. So just at this part. So for what values of x here do I see the graph decreasing or the gradient negative? So it's from 3 here to 5 here. So from here to here, it's decreasing. So I'll say the range is from 3 to 5. And notice how I didn't use these. You don't want to use these at all, because at the point 3 and at the point 5, it's stationary. There's no change in slope. We just care about what's in between them. So this is what your answer would be, only parentheses. All right, so over here in part A, what they're saying is this. It says, when is your derivative equal to 0? It's always equal to 0 when you have maximums and minimums. So if I have a graph that looks like this, we'll say I know I'm going to have my derivative equal to 0. Let's say this is f of x. So when is the derivative here equal to 0? It's whenever I have these guys here, the maximums and minimums. Because if you see, the slope at the top and bottom here is neither increasing nor decreasing. It's stationary. If it's stationary, no change. This is 0 change in slope. Alright, I'm going to show you how to find the derivative of an equation like this. If you notice, we've got fractions, and then you got to take fractions. So what you want to do is, whenever you have an x or any variable with an exponent on the bottom, you want to change it so that it's no longer a fraction. So like this one, using the laws of exponents. So this is 3x to the negative 4, because you bring this up to be with the 3, now it's negative 4. Woo. Here we go. Alright, minus, now you see this one? The x is on top, so I can just separate these two. That's actually a 1 right there. So I can make this a 1 over 4x squared. These two are the same, plus 5x. Now I do the power rule. This goes here, so it's 3 times negative 4, which is negative 12. And then you are subtracting 1, so negative 4 minus 1. And then minus 1/4. X was 2 squared right here, so I bring that here. So times 2x, and then 2 minus 1. And then plus, add a 1 here, bring that over here. So it's 5 times 1, x, 1 minus 1. So I'm left with negative 12x to the negative 5th. Negative 4 minus 1 is negative 5. And then here, negative 1/4 times 2 is negative 2 over 4. 2 minus 1 is 1, so I have x to the first power here. You can leave that off. You can leave that off if you want to. Doesn't matter. And then plus, you see it. This gives me 0, which means this becomes 1. I can just leave that out. So I'm left with 5 here. So now, in the end, I have negative 12x to negative 5. 2 over 4 is 1/2 minus 1 over 2x plus 5. Technically, you're never supposed to leave your exponent negative. So what you do is you bring this back and put it on the bottom here. So then you're left with negative 12 over x to the positive 5th power, because now we put it on the bottom, minus 1/2 x plus 5. So this is your derivative.